Hello. So now we're gonna do the Newman projections of the molecule. Here's the Newman projection, and essentially what this diagram represents is here. We'll bring in the molecular model to give a better view. So essentially we're looking down this center carbon right here, which is represented by this center on the Newman projection. This is the hydrogen as represented by the white balls. So here is the hydrogen, and the chlorine, which is over here on the molecule, is represented by the blue ball. And on the back side of the Newman projection are these three molecules: the hydrogen, the C3H5, and the C2H5. So this is the C3H5 as represented on the Newman diagram. Here is the hydrogen as represented by the white ball. And here is the C2H5, which is represented here on the molecular diagram. And here is stereoisomer 2 drawn in the Newman diagram. So as you can see, when compared to stereoisomer 1, the chlorine and the hydrogen are in different places. Now here is a molecular diagram of the stereoisomer to better demonstrate. Here is the chlorine as represented by the blue ball, and here are the hydrogens. And as you can see, they correlate directly with the Newman diagram in this format, as the Newman diagram is looking through this carbon right here. And between Newman diagram 1 and Newman diagram 2, which are both stereoisomers, they are also enantiomers. Enantiomers are stereoisomers that are not superimposable mirror images of each other. Additionally, in these molecules with stereocenters, all the stereocenters will have the opposite configuration.
So these are the two diastereomers of molecule A. Here, the chlorine is facing forward, and in this one, it is facing back. So then in the Newman projections, when looking through the C4 bond, there will be one hydrogen here, here, as well as here, which is shown in the diagram, as well as the carbons. Then, looking into the bond, we're gonna have our hydrogen, then our double bond carbon as a group, and as well as our chlorine, hydrogen, and CH3 as a group in the back. The Newman projection, however, does not show, when looking through the bond, that there is a change in the chlorine position. Because it is represented as a group, only looking at, for example, a Fisher projection, it will show the difference in the two. So the two diastereomers are the stereoisomers of molecule A. They differ by the chlorine sticking in and sticking out. Diastereomers are not mirror images of each other, so if you compare them, there's no way that they could be mirror images, and they also are not superimposable. Yeah, that's it. This is a Fisher representation of molecule C. Molecule C is a diastereomer of molecule A and B. So in order to determine whether the molecule C rotates polarized lights to the right or to the left, it needs to be done experimentally. That is because we cannot determine the sign of the rotation solely from these diagrams. However, we can determine that it is optically active. That is because it has two stereocenters, as circled on the Fisher diagram. Stereocenters must be sp3 hybridized carbons and must be attached to 4 different groups. Only these two are attached to 4 different groups. This is the sawhorse projection of molecule C. It is looking through the C4 bond.